Hi, and welcome to the vodcast, which is the introduction to the UV plane. So before I even tell you what the UV plane is, though you can see one down there, I want you to think about what is the biggest angle that you can measure. Now, there's a really good case to be made for 180 degrees, and I have a little illustration here to show you why there's a really good case to be made for 180 degrees. So if I look at these three angles, if I think about, well, here is an angle that is just a little bit less than 180 degrees, right? Like, I don't know, 175 degrees or something like that. And then if I increase it a little bit, then I was like, okay, it's even bigger now. It's 180 degrees. Okay, and if I increase it a little bit more, okay, now here's 185 degrees. Now, the thing about 185 degrees is that there's also another angle over here, which is less than 180 degrees. So once I get past 180 degrees in a way, there's always another angle that's less than 180 degrees that is equivalent. Now, the thing that I want to think about is, well, okay, that might be true, but I still talk about angles being bigger than 180 degrees. In geometry, you talked about the fact that there was 360 degrees in a circle all the time, that there's, a full rotation is 360 degrees, right? Okay, so, but in a way, that's just a construct, right? We just decided that we're going to think about this angle here, right? This black angle here that's bigger than 180 degrees. We're going to choose to think about this angle that's bigger than 180 degrees rather than this angle here that's less than 180 degrees. Okay, so if that's the case, why do we have to stop at 360 degrees? And if you are a fan of skateboarding or snowboarding or any other sport where there's rotations, you probably are familiar with using angles bigger than 360 degrees to describe turns that are more than one full rotation, right? If I have a skateboarder and or a snowboarder, and you say that they are doing a 540 degree turn, that means that they go all the way around once, right? And then they go and once they go 100 all the way around, that's 360 degrees. And then how many degrees are left after 360 degrees? Well, another 180 degrees, right? So I go another 180 degrees. So that's 1.5 full rotations is a 540 degree turn. So that's kind of cool. So why stop there? Why do I have to have any sort of limit on what kind of measurements are allowed for angles? And the answer is there isn't any reason that I have to have any sort of a limit for that. And the UV plane is one way that we can kind of contextualize what angle measures bigger than 180 degrees and bigger than 360 degrees are, and think about the relationships between those angles and allow us to conceive of angles that measure any real number at all, from negative infinity to positive infinity. So that's kind of weird, but just hang in there and it'll start making a little bit more sense perhaps. If I look at the UV plane, it looks an awful lot like XY axes that you've been drawing since you were in the 5th grade. Now, it's exactly like that. Coordinates work exactly the same way. We're just thinking about the coordinates, a point on this plane, right? If I make a little point somewhere, say it's here, right? We think about the coordinates of that plane being UV and not XY. Okay, so that is fine. I keep dragging my hand on the side of the screen there. Sorry about those weird dots that keep showing up. So it works in that way exactly like any other coordinate plane that you've had in your math career before. Now, why not just call it the XY plane? Why make it anything different? Well, we want to distinguish that there's a difference between this UV plane and an XY plane in terms of the types of objects that live there. And right now, the only object that you're going to know of that lives in the UV plane are angles, right? So angles live here. And what doesn't live here perhaps is more telling, right? What doesn't live there are functions, right? Graphs. That's a lot of what you've been spending the last few years in math looking at in the XY plane, or graphing equations or functions. And those types of graphs do not exist in the UV plane. That's something we're going to say for the XY plane. So how does the UV plane work, and how does that help us understand these angles that are bigger than 180 degrees? We're going to think about this by, instead of kind of talking about it, open-ended, we're going to look at some vocabulary that's going to help us understand this. And this vocabulary, we're also not going to write formal definitions for it. We're just going to go through and talk about what excuse me, we're gonna take each of the terms on this vocabulary list and talk about them in the context of the UV plane. We're not going to write formal definitions of these. I'm never going to ask you a question to define standard position in words, but I want you to know what standard position means. So let's start with initial ray and terminal ray. So you'll remember from geometry that all angles are composed of two rays, right? So like these angles that I drew over here to illustrate 175 and 180 and 185 all have two rays. This side is a ray and this side is an array. So the initial ray is the side where the angle starts. So the way that I drew this angle, this side was the initial ray, this side was the terminal ray, right? Initial, beginning, terminal, ending. So one side is the initial ray and one side is the terminal ray. Now in the UV plane, we have something called standard position. Standard position is saying that the initial ray for the angle is always going to be along the positive U axis, right? So this is the initial ray right here, always. Now the terminal ray can be anywhere it wants as long as the vertex of the angle is at the origin, right? So I can draw the terminal ray, I don't know, over here, right? So that would be an angle between, say, 90 degrees and 180 degrees based on your geometry knowledge before. If I'm talking about the angle that goes from the initial ray to the terminal ray like so, right? If that's the angle that I'm talking about, then this angle is in fact between 90 degrees and 180 degrees. Now the trick is that necessarily the way that I'm going to go from the initial ray to the terminal ray? Well, maybe or maybe not. I'm actually going to skip coterminal. I'm going to talk about positive direction for a second. So this angle that we drew here is in the positive direction because I'm going this way, counterclockwise. The counterclockwise direction is always the positive direction in the UV plane. So this angle is in fact between 90 and 180 degrees because I've drawn this little arrow here to indicate that this angle is the one that I'm talking about. Now that angle doesn't have to be the one that I'm talking about. If I go a different way from the initial ray to the terminal ray, let's say that I go around an extra time. So I'm going to go all the way around and then go around a little bit more to get there, right? So that was another angle with the same initial and terminal ray. The red angle and the green angle that I drew here are coterminal, right? The red angle has a measure between 90 and 180 degrees. The green angle has a measure between 360 plus 90 and 360 plus 180 degrees, right? 360 plus 90 is 450, 360 plus 180 is 540. So the green angle is between 450 and 540. Now that's not the only way that I could get there. Those are not the only two ways. I could go backwards, right? So let's say I go this way, right? That is another way that I could get there. Now I didn't go in the positive direction, so this angle is negative, right? And since I'm going backwards a little bit more than 180 degrees, this angle is going to be between negative 180 and negative 270, right? Which is that far around. I could, if I were feeling crazy, I could go around a bajillion times, right? And then land on this angle, right? If I think about all of the angles which are coterminal with this terminal ray, they all have a full turn extra going on, right? So let's say that this initial angle that I drew in here, let's say that it was 130 degrees, okay? So 130 degrees is between 90 and 180, just as I said. If I add 360, if that was the red angle, if I add 360, this is going to give me the green angle, right? If I subtract 360, that's going to give me the orange angle. If I add 360 23 times, right? 130 plus 360 times 23, that would give me an angle that is coterminal that involves going around 23 times. So all of those angles are coterminal. So that's the basics of how angles live in the UV plane. The one term we haven't talked about yet is reference angle, and to talk more about this, we're going to look at that other handout that you have for this podcast. Okay. So this is talking about reference angle, and I want to go through this first question close together, and then I think I'm going to let you finish up some of these on your own. So the reference angle, and I didn't talk about theta. So this guy here, right, this symbol is a Greek letter, and it is the Greek letter theta. And we often use the Greek letter theta to refer to angles, right? It's just a convention. We don't have to use theta. We could use a different variable, but we often use theta to talk about angles. And we're going to use theta a lot of the time here. So the figure shows an angle theta, which is 152 degrees in standard position. We talked about standard position. This one is in standard position because it has its initial ray, it has its initial ray along the positive u-axis, and it has its terminal ray somewhere else in the picture. Great. Now let's look at this definition here. The reference angle, theta ref, is how we're going to say that. That's a subscript. It's not an operation. It's just like specifying which theta angle I'm talking about is the reference angle, theta ref. And let's read this sentence carefully. Is measured counterclockwise between the terminal side of theta and the nearest side of the horizontal axis. Okay. Between the terminal side of theta. Where is the terminal side of the angle theta? Well, the terminal side of the angle theta is this here ray, right? This is the terminal side. That's where that angle ends, okay? And the nearest side of the horizontal axis, that's the u-axis, that's this guy here. Where is the nearest side of the horizontal axis? Well, it's not this one, it's this one over here, right? This is the nearest side of the horizontal axis. And it says it's measured counterclockwise. Okay, so that means that I'm going to go in the positive direction, the counterclockwise direction, and this angle here is going to be, is going to be theta ref in there, okay? That's theta, the reference angle, theta ref. Now, in this case, right, that's what it is, and to calculate its measure, well, I know that the actual angle theta, right, 152 degrees, and the reference angle together are supplementary, right? They measure 180 degrees altogether. So I can say that theta ref for this case is equal to 180 minus 152, which is equal to 28 degrees. So that is the measure of my reference angle for this picture. Go ahead and try number 2 on your own. Pause this podcast, go ahead and do it, and I will be right back. Hopefully you paused it. Did you do it? Okay, hopefully this is where you drew your reference angle, right, the terminal ray, and then the closest side of the u-axis. The angle is still measured in the positive direction, so it's this angle here going counterclockwise. In this case, I'm not going to add or subtract from 180 to get the reference angle. I know that the difference between theta and the reference angle is 180, 250 minus 180 in this case. 250. Whoa, what is going on? 250 minus 180, in this case, that is 70 degrees, right? So this is plus 70 degrees here. And then if we look at number 3 together, it says you should have drawn arrowheads on the arcs for reference angles in problems 1 and 2. You did, hopefully, if you drew them like I did. Explain why the arc for 152 degrees goes from the terminal side to the u-axis, but the arc for 250 goes from the u-axis to the terminal side. What's this question really saying? Is that over here, right, the initial ray for the reference angle was the end of 152 degrees, right? And then the terminal ray for the reference angle was the u-axis. Now, if in number 2, the initial ray is the u-axis and the terminal ray is the end of the 250 degree angle. And the reason why it's not the same for both of these problems is because the reference angle is defined to always be positive, right? It always has to go in a counterclockwise direction. And I wouldn't be able to have the terminal ray and the initial ray the same if I wasn't always going in a positive direction. Okay, there you have it. So I think that what I would like you to do now is to go ahead and finish this by yourself. Go ahead and check all your answers against the solutions, which are posted on Schoology, and make sure if you have any questions that you check with your instructor during the next class. That is all.